Okay, fine. Okay, so we till now we saw how the map phase works. Okay, the reduce phase also. Okay, we'll just focus on one simple program, the famous uh, program called word count program. So anybody want to learn MapReduce, they start with the word count program. That is finding a occurrence of each word in a given simple text file, right? I will take this, right? Somehow I don't know my. Okay, yeah, this is somewhat visible. You are able to see this picture which I taken from the Google.
Yes, Pari.
Yeah, thank you so much for confirming. Okay, so so I'll take this as an input file. Okay, so similar like what we had a sample.txt. Okay, there is a content text called bus, car, train. This is uh, just uh, just these are the words. There's some random words you have it in the input file, right? So consider this. They're considering this as your input file. Okay, so take this is one block. Okay, what happens is so as I told you, this will be a coming a key value pair. Your key is the offset, just we are not going to use it, the line number may not be used it, but the value is the entire line, we are going to use it. So basically we just want to find out how many like the number of words occurring, like a bus is occurring 3 times, okay, car is twice, and plane is twice, and train is twice. Okay, so this is the output we have to get. Okay, so so if you want to do this is in simple Python or Java program, we can do it, but we just want to understand how in a MapReduce programming model that can be achieved. Okay, this is a just simple example, but if you have a large documents which has some newsletter documents, so if you want to do word count on those, it will be huge, right? So or maybe all this Google does indexing based on these things only, but we'll just understand for understanding purpose, we'll take this simple example, but later we'll go a little more real-time use cases. Okay, so this is this is a when this line comes as an input to the mapper, this will be a value 1, and this is a value 2, this is value 3. Okay, what we are doing is in the mapper, so uh, this is a map output. In the mapper, what we are doing is we are just tokenizing the string. Okay, so just splitting the string into words by using the space separator. Okay, so when you do uh, this is a string um, type. Okay, if you split, it will get you will get a words. So bus and car and train, and then so you know the when you in the mapper or the map task, when you want to write your output, in the output also we can write in terms of key value pair only. So what we can considering is key as a the word, and value as the we are assigning counter, like say just assigning 1 for all the words, we'll just assign 1. Okay, so your key will become your word and value will become the counter, which is a 1. So this is the first key value pair has come to the mapper. So it generated three key value pairs. Bus is a uh, key 1, and value the 1 is the value 1. So similarly it generated 3 key value pairs. This is the second line, this is the second line came to the mapper, and it also generated 3 key value pairs. Similarly third line generated. Okay, so this is how the intermediate data will be written on uh, your disk. Okay, so then it actually shuffles, okay, and send it to the reducer. Okay, so in the reducer, so while actually uh, during the shuffle and sort, what happens is simple, it's going to do the grouping based on the key. Okay, by default the shuffle and sort what does is whatever the key value pair, this in this is like a simple word count program. Even whatever business logic you write for your real time scenario, whatever key value pair you pass, the shuffle and sort will do. It will just group based on your key. Okay, whatever key you pass, it will just group based on key, and the all value will be grouped. Okay, based on a key, your value will be grouped, and it will send key as a basically the grouped key as a key to the reducer, and entire grouped values as a value to the reducer. So example. So okay, so if I take this the inputs, right? Say bus as one and car as one, train as one. Okay, and similarly, uh, this is the first result of first key value pass from the reduce mapper, and train one and plane one and car one, and from this has become bus 2. I will tell you why it has become bus 2, but for the simplicity sake we'll just do similarly. There is something called uh, uh, there's something called a combiner. Okay, actually which actually does the aggregation in the map, the output of map. Okay, so because of that only it become bus 2, but just to will go in a simpler manner, this will become like this generated bus 1 and again bus 1 and then plane 1. Okay, this is your output of map task. Okay, so when it comes to reduce, okay, when it comes to reduce phase, or I'll just say reduce task for simplicity. So when it comes to reduce task, what again reduce task also takes key 1 and value 1, and it will return it will also write the data in terms of key value pair only. So just you are just you can record this, probably you can, or maybe you can just note it down. Being a map task or reduce task, it receives input as a key value pair, it can write result as a key value pair. This is the main concept, nothing else. So what will be the so if this is has been output of map task, what is the input of the reduce task? I told you shuffle and sort pace, the keys will be grouped. So say example, if what is the how many distinct keys there? We have four keys. One is a bus, car, train, and plane. So uh, just does that key shuffle and sort. So you will get a bus as a first key and the grouped values. So how many bus are occurring? Um, three. Year one and year is two. So one comma sorry, one comma one. This is the grouped key, and these are the grouped value as a I trouble. I trouble, I say it's a means it's a collection. Okay, and similarly for second key K2 V2, this is the one key value pair to your reduced task. What is the second key value pair to the reduced task, which is a car? Car is occurring twice from the map input one and here. Okay, so one and one, and then train also 1 comma 1, and then plane similarly 1 comma 1. So this is the your input to the reduced task. Then in the reduced task, so already the values been grouped. Now you just have to sum up and find the aggregate. Then I will just iterate. So because every time I know only this. So in the map task, this is the first input came. So I take key as bus, and value I'll just sum of this three values, then it will become 3. Okay, so then I will be writing this is the one of the result from my reduce task. So I will be writing bus 3, and I will get a next key value pair as car, and its grouped values 1 1. Then I will make car, and I'll just sum up and give it 2, and then I will third key value pair as I'll make it as train, and I'll just give 2, and finally the plane, I'll just 2. Okay, so this is how the MapReduce task works. Okay, so you are taking input split, which is like one block, and you are actually what you get is a key value pair, like value will be your line, entire line. So you just doing the tokenizing your string into the line into words, and assigning the counter, and this will become your MapReduce map task output, which will be shuffled. What in shuffle and chart will do, basically it will group their key, and then gives the grouped values, key values to the reduce task. In the reduce task, you just sum up or do whatever aggregation you want to do for the grouped values for the key, and you just write the result into the again the SDFS. Okay, so so you have any question in this?
No, Pari.
Okay, all right. Thank you. So, so this is the this program. This is the diagram depicts. Okay, and I will show you one more. Okay, so this is okay. Okay. So this is little more. I what almost I told all the things, but I will just give you few more information here. Okay. Uh, so you store your input data, the block in HDFS, right? So uh, based on the so basically okay, your block is stored, but so basically when you store a file into SDFS, okay, so you know what is the type of your file, means what is the format of your file, whether it's a file what is that, sorry, text input format, or it is a park. There is other file formats like parquet and binary, which is a sequence input format. There is also multiple key value format. There is multiple file formats. Okay, so I'll just file formats in Hadoop. Okay. Okay, I'll give you the list. Okay, so it has text input format, sequence input format, and it's not visible properly. Okay, those are the different file formats is there. What I was trying to say is, okay, so depending upon the what file format your data is stored in SDFS, you need to use that respective file format class when you write a MapReduce job. Okay, that is what I want to convey that. Okay, so I'll just show you the. So when we saw this demo class, I'll just show you only one. I will not explain you much. But so if you see here, this is my. This. So when you write, this is the driver program I said, where you configure your jobs. So I'm just initializing my job. Okay, there is a job class. It's basically you are creating a MapReduce job here. Okay, job client, and here you have to specify what is the file format which I'm going to process in the MapReduce. This in map and reduce task. Okay, the MapReduce, what is the file format I'm using. So I know I'm going to read a input split, which is a block, and I am going to take the key value pair and process. But what is that format? What is the file format? The data is being stored in HDFS. If I know that only, the respective for each file format, it has libraries how to read that file. Okay, so that is very important. So that is the input format. Okay, so based on the input format, okay, so you take the input split, and there is something, there's a function called record reader. So each file format, it will have a record reader. So in the record reader only, we'll have the logic of reading your files. So basically from your block, how to take the key value pair. Okay, so how to form the key value pair. Okay, with the text input format, what it knows is uh, text input format, every line will have the end of line break. It's a slash n, right? Wherever you find the end of line, it will generate one key value pair and give it to the mapper task, map task. So that is the function use of record reader. Okay, so the record reader is the one which generates the key value pair from your while reading the input split, and it give the mapper task. So in the mapper, we know like it will take your input key value pair and does the transformation and give the intermediate data. And there is a one more I told you, right? There is a combiner. Okay, uh, okay, why this has become they show it as bus 2 years here. So there is a uh, um, there is a small concept called combiner, which does aggregate on the map side output. Okay, so whenever the mapper writes intermediate output, we can write a simple aggregation logic, so we can apply it on the output of the map task, so that you don't need to pass your multiple key values. See, if it is a already uh, this is say example, this is a one task running on node 1. Okay, till this is this three are generated from node 1, and these three are generated from node 2. Node 2. Okay, and this is generated on node 3. Okay, so finally I have a node 4, which where I am going to run my reduce task. Okay, so what happens, all this key value will be taken and given to the reducer shuffle during shuffle and phase, and the data will be flown from here, and it is given to the reducer task which is running on node 3. So here if this is from one node, this is no from the node 3, this output is taken, this output of mapper task, and it will be given to the reduce task. So instead of just passing multiple, so I know this key is already means repeating here, right? So I can do the aggregate itself, and I can pass, so that I can reduce the network transfer, the transferring of data to the network to the reduce task. Okay, to avoid the lot of data which is moving from the map node where map task is run to the reduce task, to avoid that network bandwidth. Okay, so passing a data to the reduce task, we can apply the small aggregation here, and whatever which we are going to do in the reduce task, so that this will be counted here. Okay, so that function is achieved through the combiner functionality. Okay, so they call it as mini reducer. Okay, combiner also does the kind of aggregation task. Then I told you that a partitioner which actually decides which key value pair has to go to the which reducer, and there will be a shuffle and short pace, and then it gives the grouped values to the reducer based on the key as a key value pair to the reducer. Then it does aggregate, and it has to write into HDFS, right? Again, the writing also decided based on, okay, anyway the reducer will write as a key value pair, but there is a writer method which has to know what is the format you want to write it to HDFS. Based on that, that particular logic will be executed. So if it is a text input format, so it will take a one key value pair, and that will be taken as a one line in your output. So it just put the end of line for every key value pair, and it will write in HDFS. So if it is a sequence format, so it has to write in that way. So in the overall MapReduce job flow, these are the different concepts will be used in the MapReduce job. Yeah.
Pari, I have a question here. Like,
sure.
To execute all this workflow, do we need to provide separate Hadoop commands, or just how it works? Do we need to provide for each step we need to provide commands, or what?
No, only one command I will tell you.
Okay. Yeah.
Okay.
Yeah. If you can provide those commands as well, it really helps, Pari.
Sure. I will do. We'll actually tomorrow. I will just build the jar, and I will run for you and show you. Don't worry. Okay. To
Sure,
just.
Pari. Thank you. Yeah. Yeah. Okay.
All right. What I'll do is. Okay. All right. Okay, this is the one of the MapReduce job for. Okay, so whatever the mapper and reducer code you write, finally you will build as a jar. Okay, there is a executable called jar in Java world. Okay, so example, just leave about whatever code, all your code will be packaged one file called dot jar. Okay, what are the file name you give? Dot jar. Okay, this is your entire the packaged job. Okay, and in this, so all your Java class files are packaged in a file called dot jar. This is the jar you need to going to pass it to the Hadoop. Okay, hey, this is my job, just run it. Whatever the information you need, basically where is my input, where my output has to be written, what is my input file format, what is my output file format, all the information I given in this jar, you just take the information and do the job. That is the one you are going to do. You're just going to run this command. You are not going to do anything else. So all this phase will happen. This all the phases are the the background MapReduce job life cycle. Okay, but what as a user, I just run this command. That's it. I run this command. After the completion, I'll go and refer my output directory. Okay, so my output will be there. If any issue is there, then I have to go and debug it. But if my job is successful, I will see the output in this directory. This is the one line you are going to execute, nothing else.
Okay, Pari, got it.
Yeah, sure. Thanks.
Yeah.
All right. So,
Pari, just a doubt, in case if we got any issues, the error will be displayed over there itself, or like it will be showed some other place?
so some of the error you see, basically This is the okay. So
Usually we
there
run this command on the HDFS command prompt, right?
we'll be running on console.
Yeah,
Okay,
HDFS
so
console.
one way is writing into console, right? So
Yeah.
I'll just okay, say example. This is our uh, cluster. Okay, so okay, this is our Hadoop cluster, right? So we can actually submit a job from job in multiple ways. One is the job client, command line job client. Like CLI, like how we do HDFS command, or you can use Java APIs. Java APIs, like this is also job client only, but in terms of Java API. Say example, I have a Java application, okay, which is running outside my cluster. Okay, from there I want to submit my job to the cluster. I can do that, but most of the time we will do this only job client from the CLI. Okay, so to answer your question, yes, some of the error you might get it in the console where you run. Okay, that is if any most of the error with respect to driver program. I told you there will be three programs: driver, mapper, and reducer. Okay,
Yeah.
and you see some of the error you might see in the console itself, and at least the failed information will be shown there. But more detailed information, you have to go and look the log. The log can be seen. You just log into the respective node and you can see, or there is a dashboard given for the MapReduce jobs. Okay, so for the Hadoop version 2, there is a yarn dashboard. Okay, where you can go and monitor your jobs and and, and track your issues if any faced. I will show you tomorrow that yarn dashboard. Will run a sample job and will just run a job from CLI, and we'll just go and check the logs in the yarn dashboard as well as manually in the particular machine's Linux directory also.
Yeah. Okay. Fine. So and one more thing, like, so the log path will be same for all the machines, like, or it depends on the project and it depends on the requirement.
Which one? Which one?
Log path. So usually we will check the log path in the nodes, right? So
Yeah.
that
So
directory path will be there, right? That will be defaultly configured for all
yeah.
the
So
machines, or like.
So mostly it will be based on the cluster setup. Okay, so mostly it will be, like say example, it is based on the what distribution of Hadoop you use. Okay, so what we are going to learn is the Apache Hadoop. So Apache Hadoop we can decide wherever you install, right? So example, I will just show you the. So if I am using Apache Hadoop, I am the one who is going to just set up, right? So basically for learning purpose. So in that particular installation folder, I can just check it. Say if I think Santosh or somebody else using the Cloudera VM, which has some default location where the logs will be stored. If somebody else is using Artonworks Hadoop distribution, the log will be some different place. It depends upon the what distribution of Hadoop. Okay, so if I am introducing or maybe using the word called distribution first time, distribution nothing but what is the flavor of Hadoop. See, open source Hadoop is the one, okay, but as different companies like Cloudera taken the open source Hadoop and they add some extra features to that, and they will give for the commercial usage. Okay, so so that's how the distribution terminology comes. And log, yeah, as I mentioned, log file will be depends on the based on your Hadoop installation, cluster installation.
Yeah, got it, Vinny.
So, but mostly everybody will have yarn dashboard. So like as a like
So
you don't need to worry.
yeah, user interface. Yeah.
Okay, let it start. Before that, I want to show you. Okay, so this is as a like at a high level, right? So they basically they all these components will be like backend. These are the phases it goes through the job execution. Okay, there is one more diagram which I want to show. Okay, um, so this is the like I told you in the MapReduce, sorry, Hadoop one, MapReduce one. Uh, there is a task job tracker which is a master process, and there is a task tracker which is the a slave process. Okay, or the one which does the actual execution. Okay, so your job will be submitted to the job tracker. So I'm talking in terms of Hadoop one. This is for just for your knowledge purpose. But when you go to almost I don't think so people maybe there is a um, 5 to 10% of people might be working in still Hadoop one version, but most of the people, 90% of the people work on the Hadoop version 2. Okay, so this is for your knowledge purpose. I'm giving this information. So in the Hadoop version 1, the job tracker to the job tracker will be submitting your jobs. So job tracker knows like how name node knows the disk availability or the data availability, the space availability about the your data nodes. Similarly, job track knows which are the node as the resource to run. So when you want to run a job, you need actually RAM, and where is your input is where is input is located is basically depend or maybe the information is known by the name node. Job tracker knows where is my resource, the CPU and my RAM is available on which node. So based on that, it initializes the job and converts your job into so anyway it's you have a map task and reduce task, right? So it just launches the map task on every task taker, okay, where your blocks are located. And the once this task taker will take the input of your the input blocks, and it will run the map task and write the result in the intermediate disk in the particular machine's slave node. Okay, then the result will be taken to the reducer node. So reducer task also will be running on any one of the data node by the task tracker. So task tracker is irrespective of map task or reduce task. This is the one is going to run. Okay, and then the result will be written to the HDFS. Okay, and one more point I want to mention: when you submit, so I told you, right, there is a one. Okay, so when we run this command, right, so we'll be running this in CLI. So basically, internally, what we are doing is we are just giving a information to the job tracker. This is my job. So what job tracker does is it actually ships your code. Okay, uh, take your code and it will ship wherever it want to run the task. Being a reduce task map task, it ships your code to the node and it will tell this is my your input split. You just run. So the code will be shipped to the respective data nodes. Okay. So unless the traditional system where you pull the data and you process on it, but in MapReduce, your code will go to the where data is sitting. So that is that terminology called data locality. Okay, so your code will go to the where data is sitting. Just have that information. And this is with respect to Hadoop one, which is the MapReduce one, and MapReduce two. We will talk in more detail when we comes to the yarn. Okay, I will actually have a separate uh, session where I'll explain each process of your um, the yarn, each how the each process of yarn works. Okay, so in the MapReduce 2, so I told you there will be a resource manager, there will be a node manager. Okay, so resource manager is the master process. So that is the one which takes the job and it delegates works to the the node manager, and which actually launches the container to run your job. All this information I will take one separate class. Okay, so no need to worry. We'll cover in the probably the one of the session. Okay, so what I want to understand is this is the flow. Okay, this is one diagram which actually you can explain in the if somebody asks you how the MapReduce job works, theoretically this is the one you can explain it. You have any other questions?
No, Pari.
Okay, all right. So we can actually stop here. Okay. So in the next class, tomorrow morning, actually, tomorrow I'm traveling to my native. So morning time, I'll be traveling. So we'll have tomorrow alone. Shall we have it in the my 9 p.m. IST time? Is that okay
Yeah,
for you?
10:30 AM. Yeah, fine, Pari.
Okay. So what we are going to do tomorrow is basically we are going to execute the MapReduce job. Okay, I will explain you the program. Okay, so just sorry for people who are non Java background. Just I will not go just to bore you to explain. I'll just explain in a simple way. And in Java version of code as well as the Python. Okay, just you can maybe start focusing on Python, but just to learn what is happening in Java. Okay, because Java knowledge will be used whenever you want to debug your system. That will be my input. Nothing is my input basically. Java knowledge will be very useful when you want to just debug or maybe understand what is the issue actually. Just to giving you, but it will not give you the entire information about your error, but at least the pointer it will give you that. Okay, but when you go to Spark, anyway, we are going to use the PySpark. So Python is very important. I will just give you tomorrow the small basic concepts in Python and Java. Just I'll for what you need to know when you want to understand this MapReduce job. That information I'll give. That is enough for you. And for based on your interest, I will not restrict. You can just go and learn Java and Python both. I don't stop anybody.
Yeah, sure, Pari. Sure, Pari.
Yeah. um Anything else? I think that's it from my side. If you don't have any question, we can stop here.
Yeah, we are good, Pari.
Okay.
Yeah.
Okay, thank you so much. See you tomorrow.
Yeah, thank you, Pari. Have a good day.
Have a good day. Bye.